Hello everyone, welcome to lesson M4 on force, pressure, and area. Now this is taking a look at how pressure and mechanical advantage relate together. Now we have discussed this before, so pressure is equal to force over area. And we did talk about pressure within the first unit, and so we're kind of dealing with it again. So excuse me if some of this looks a little bit like review. Now, I'm going to assume that you have watched these two videos already. And so if you haven't, please watch these two before we continue on. Okay, seeing that you're continuing on, I'm guessing that you've watched those two videos that I've asked you to. So first of all, a force acting over a certain area is called pressure. And when you change the area and keep the force constant, the pressure actually changes. An example, snowshoes over your body weight stays the same when you wear them versus shoes. But the area increases, and so the pressure actually decreases. Your body weight stays the same, but the area actually changes. And we'll take a look at an example of that in a moment. Remember, force is measured in newtons and area in square meters. And so the unit for pressure is the Pascal or the kilopascal. Now, remembering that a kilopascal is really just equal to 1,000 pascals. So here's the question that we were talking about here. Carmen's weight is 50 kilograms, so the force acting on her underneath will be approximately 500 newtons. That is her weight on Earth. Now, if we take a look here, being that pressure is equal to force over area, we're going to compare she's standing in the snow on one snowshoe or standing in the snow in one boot, right? So she's standing one-footed, right? And the question is whether she's just got a boot or a snowshoe here. So we're looking for the pressure, 500 newtons over an area of 0.2 meters squared in the case of the snowshoe. And so the pressure with the snowshoe is 2,500 pascals or 2.5 kilopascal. And again, that's for the snowshoe. But we're keeping that same force. However, underneath the boot, we've got less area. And when you calculate that out, you get 10,000 pascals, or a pressure of 10 kilopascals, and that's for the boot. Notice as we decrease the area, we increase the pressure. Force stayed the same in this case. Okay, I would like you to try practice question number 2. Pause the video, and then we'll come back to it. So pause, try it, come back to it, see how you did. Okay, so here again, you've been given 90 newtons of force that's actually hitting here. The weight and speed that the person's traveling at just give you an indication of that 90 newtons. So we're using the 90 newtons. Hitting with the entire face on, let's say, an airbag leads to 1.8 kilopascals of pressure, where if you just hit your forehead on the steering wheel, it winds up with 10 kilopascals of pressure. Now, there are certain pieces of equipment that are designed to reduce the amount of pressure, but not all of these just reduce pressure. Sometimes they reduce the amount of actual force that the person is experiencing. A seatbelt is one example of this. Now, a seatbelt is going to reduce the force by increasing the time of impact. that you're going to experience that impact over a long time. The more time you take a blow, the less force you're going to actually experience upon that object. Now, the other thing this is going to do here, it's going to reduce the pressure by increasing the area. So first thing, we're trying to reduce the actual force, and second thing, we're going to increase pressure. And in fact, pretty much all of these devices work that way. In the case of a boxing glove, rather than hitting, the boxing glove is going to compress a little bit, which is going to increase the amount of time. And all of this area here, rather than just the fist inside, is going to actually increase the area, thus reducing the pressure. In the case of a helmet, the helmet on a person, as first of all this blows, you're going to wind up increasing the amount of area that's going to be applied to your head. But as this helmet crumples, especially bicycle helmets, that's going to reduce the actual amount of force. Airbag does the same thing, where if you've got a big airbag as opposed to just the steering wheel, and so as you're driving, yeah, I know, really long arms, but as you're driving, you're going to get your whole face rather than just the forehead, and this airbag is going to compress in order to actually decrease the force. So all of these safety devices do two important tasks. Again, the first thing, they're going to reduce the force by increasing the time of impact. The more time of impact, less force gets transferred. And we reduce the pressure on any one point by increasing the area in which you take that impact. Thus, also less force applied to any one point. Now, Pascal's law, oops, didn't mean to do that. Pascal's law says that the pressure exerted on contained fluid is transmitted undiminished in all directions throughout the fluid and perpendicular to the walls. That means if, let's say, I've got kind of a tube here, and I'm going to put some sort of syringe here. If I apply a force here, the pressure is going to be perpendicular to the walls in all directions, and even out this side, so we can actually transmit that pressure all throughout this tube. Now, many mechanical systems use Pascal's law, for example, hydraulic lift. Now, a hydraulic lift is basically a hydraulic system that uses a liquid under pressure. Now, this is another thing. It is a closed system. Now, a closed system is really just a self-contained collection of parts. Now, because we've got a liquid in here, it makes sense that you would want to contain it, otherwise all the liquid would come out. An example of a closed hydraulic system in our body is, in fact, the circulatory system. Kind of one example of that is figure 4.32a from your textbook. It looks something like this. Okay, where we've got two hydraulic presses, one on either end. We've got a fluid in here, and I think they've actually got the little arrows pointing along too, showing perpendicular pressure being transmitted throughout. And the pressure, again, remember, is the same throughout. Okay, and so the pressure is the same. Throughout. But the force acting on here and here wind up being different because of the area, right? But areas are different. Now, if the pressure is the same and the area is different, that means different amounts of forces are going to be at F1 and M2. So this all leads to different forces being at F1 is not going to be equal to F2. Now, in here, something like this would usually fill this with oil, because water is not good for two reasons. First of all, it's not a very good lubricant. Keeps a lot of friction, and it tends to rust things. Now, hydraulic liquid lift uses a liquid to produce an output force, right, on the load, when that should be an input force, effort force, is exerted on the liquid. And because those forces are not the same, you actually wind up with a mechanical advantage. That can be determined, again, by the force on the output, which is the load, divided by the force on the input, which is the effort. Okay, if you've got any questions, let me know. Thanks for watching.